Hello and welcome to this video. If you work with large data sets in Azure Data Explorer, Microsoft Sentinel or any Kusto environment, you know that the raw data is often overwhelming. You don't just need logs, you need answers. This is where the KQL summarize operator comes in. It is the most important operator for data analysis. It allows you to aggregate and group data, transforming millions of rows into a few meaningful metrics. Let's start. Although we have seen the summarize operator in one of our previous videos, I thought maybe it is better to show a better application of summarize operator in a much detailed format. And this video is a result of the same. The summarize operator has two main components in it. One is the aggregation function and the other one is by clause. Aggregation function basically says what calculation to perform, and the by clause is to show how to group the results of the aggregation function. There are many basic functions available in aggregation operator, and the basic functions include count, sum, average, min, and max. For the purpose of this demonstration, I already have created a couple of dummy data sets on top of which we are going to see how we can perform the summarization. In this table, we have three columns: transaction ID, price, and quantity. When we have the aggregation operation happening in our KQL query, it is going to return just a single row output. For demonstration purpose, I'm going to add a summarize operator here, and then I'm going to create a column called as total transactions, and it is going to be a simple count of column. I'll also create one more column called as total revenue, and this I'm going to use a sum function with price times quantity. If I'm going to execute this, it is going to return me just one record with two columns: total transaction and total revenue. The next example is using the grouped aggregation, that is the by clause. The by clause is usually used to group the aggregation function's output for the different combination that's specified in the by clause. For this purpose, I've already have created a separate data set where, in addition to the existing columns, I've added a couple of other columns: region, category, and city. Here I'm going to show the summarize operation, but it is going to be grouped by different combination of columns. Again, I'll include a summarize function here, and then I'm going to create a total revenue column here, and this total revenue is going to be having the same function, same calculation of price times quantity, and then I'll add a transactions column which is going to be a simple count. In addition to this, I'm going to use a by operator, and then I'm going to say group my summarize operation by region and category. On execution, this is going to return me four columns: region, category, total revenue, and transactions. The reason that we are having four columns is here the total revenue and transactions measure are now grouped by region and category. The third example that we are going to see here is using the advanced functions of dcount and makeset. Dcount is usually used to get the distinct count of values, and makeset is used for set creation. We also have a makelist function in KQL that can be used to create lists in KQL. As you see here, I have three columns: timestamp, user ID, and page URL. Now I'm going to summarize this log data with creation of couple of columns. I'm going to include the operator summarize. Then I'll say I want to get the first login time, and this first login time is going to be min of timestamp. Then I'll say I want distinct pages visited, and this is going to be a simple dcount of page URL. As I said, dcount is going to return me the distinct count of records, and I also say that I need all visited pages information. So here I'm going to use a makeset operator, and this makeset operator is going to return me a unique list of all page URLs. Now I'm saying I want all these information, but this has to be grouped by user ID. Basically, this says for a particular user ID what is the first login time, how many distinct pages they have visited, and how many pages they have visited as a set. On execution, this will be returned with 4 columns, namely user ID, first login time, distinct pages visited, and all pages visited. Here it says for user A101, the distinct pages visited is 2, all pages visited is home and products, and makes it automatically handles the uniqueness within the list. The last but not the least example is the time series analysis. This time series analysis is going to involve a bin function. This bin function is basically used inside the by clause. This rounds your raw timestamp down to uniform intervals like say hourly data or daily data. That is, this bin is going to be used to bin the records for each hour, each day, each month, each week as required. Going to the next example, this service security events. So this has 2 columns, timestamp and severity. Let's see how this severity is grouped for each hour. For the demonstration, I am going to include a summarize function here, and this summarize function, let's say, is going to return a column called as alert count, and it's going to be a simple count of records. And I will say this alert count has to be grouped by something. That something is going to define what is the time series analysis. I will say I want to have a column called as time bucket, and this time bucket is going to use the bin function. The bin function, as you see here, has a syntax of value comma round. The value is going to be the time column, that is the timestamp UTC column, and the grouping has to be done for 1 hour. And then I'll also say I want this to be done for severity also. Then for understanding purpose, I'll sort this by time bucket column, which we have created now. On running this query, you will notice all the events between 10 and 10:59 are grouped under the 10 bucket, and events between 11 and 11:59 are grouped under the 11 bucket. Basically, this structure is very essential when we want to do charting and trend analysis of time series information. As you see here, for the combination of severity and time bucket, we are having the alert count. So low severity alert for this timestamp has happened twice, and high severity alert for this particular timestamp has happened once. So we have covered most part of the summarize function. But before closing this video, let's also take a look at some of the common pitfalls that are there while using the summarize function. While using the summarize function, it is always better to use the filtering, that is the where clause, and the transform columns like extend, project, project away, project keep, all these before the summarize function. This helps to minimize the number of records that are going to be actually part of the summarize operation, because summarize operation is going to take a little toll on the computation, and as much records as we decrease, it's going to improve the performance of the summarize function. And a big pitfall that has to be considered while using the summarize function is the summarize function generally ignores nulls. So if you need to count those nulls, you need to probably use a conditional count like a count if is null combination. Also, it is a better approach to always alias your summarize operation like we did here. Like we are using alert count equal to count. So we are aliasing for better look and feel purpose. That's all in this video. If you like this video, please like, comment and subscribe for further similar videos.